Hello and welcome. In this video, we're going to be talking about definite integrals, understanding what they are, and solving questions involving definite integrals. So first of all, let's recall what was integration. Okay, integration was basically a tool to find the area under a graph. So let's say this is y, this is x. We have a graph of y equals x squared, so something like this. Okay, let's say I want to find the area under the graph. First of all, what's the area under the graph? Area under the graph means the area from the curve to the x-axis. So let's say I want to find the area from here, which let's say this is x equals 1, and over here is x equals 3. So the area I'm trying to calculate is basically this area over here. Okay, so how do I do that? By using a definite integral. So this could be written as our normal integration sign. However, what's different from the indefinite integral is that now we have bounds, lower and upper bounds. Our lower bound is 1 because we're integrating from 1, that's our starting point. And the upper bound is 3, that is our endpoint. So if you want to integrate from 0 to 100, so you put your lower bound to 0, upper bound 100. So what you can do is you can choose your starting point and your ending point and plug them in the integral over here. And then we integrate x squared with respect to dx. So let's recall the same exact thing, however, for a normal indefinite integral. I think by now you're supposed to know how to use the power rule to solve this one over here. So let's solve it together. So power rule gives add 1 to the power over the new power and then plus c. Okay, so this is the answer to the indefinite integral. What is the answer to the definite integral? The first step is always the same. We're going to do normal integration. So this also we're going to use the power rule here. So it's going to be x cubed over 3. However, we need to compute it from 1 to 3. Okay, what does that mean? It means that we need to plug in 3 in, substitute 3 in every x, and then minus substituting 1 in every x. What does that mean? It means that this is going to be, first we're going to substitute the upper bound, so 3 instead of x, so 3 cubed over 3, and then we subtract the lower bound substituted into x. So instead of x is going to be the lower bound, which is 1 over 3 over 3. So this is going to be 2 and it will cancel with this one, so 3 squared is 9, so this is equal to 9 minus 1 cubed is 1 over 3, so 9 minus 1 over 3 is basically 26 over 3. So my answer over here is going to equal, I can just neat it up a little bit, is going to equal basically 26 over 3. So I want you to look and identify the differences between the indefinite integral and the definite. This is the definite, means it's defined, it has a definite lower bound and an upper bound, so definite integral, and this is indefinite integral. Okay, over here the first thing is that our answer is actually a number, a value. However, over here our answer is an expression, it's in terms of x. Second thing is that over here we can see that we do the constant of integration, we have a plus c, and over here we don't include plus c, there is no plus c, there is no constant of integration. Why is that? Super quickly, again the same thing from 1 to 3 x squared dx. I will integrate, so this is going to be x cubed over 3. Let's say I want to add the constant of integration, so it's going to be plus c. I will show you why we remove it, because over here when we substitute, this is going to be 3 cubed over 3 plus c, that is the first x substituted. Okay, and then we subtract the second lower bound. So it's going to be 1 cubed over 3 plus c. So over here you can see that at the end we're going to have a c minus c, so the c cancels, and it's only going to be this minus that. So that's why we don't include the constant of integration in indefinite integrals. So I think by now you have an idea of definite integrals. I meant we don't include the constant of integration in definite integrals. So now you have an idea. Definite integrals is used to find the area under the curve or to evaluate a certain integral. We have our answer as a number, as a value, and we don't include the constant of integration. So let's try and take some examples to see how this works in different scenarios. So first example, let's say we have integration of x squared minus 2x dx, okay, and our lower bound is 0 to 5. So how can we do this? Again, the first step is super simple. We integrate normally. So this is going to be x cubed over 3 minus 2x squared over 2, or basically this 2 and this 2 will cancel, so basically minus x squared. And then evaluated from 0 to 5. So this is going to equal 5 cubed over 3 minus 5 squared. This is the first upper bound substituted inside, and then we subtract the lower bound substituted inside, which is 0 cubed over 3 minus 0 squared. So this whole thing becomes 0, and over here I will have 5 cubed over 3 minus 5 squared. This is going to give me an answer of, okay, 5 cubed is 125. Divide 3 minus 5 squared. This is going to give me an answer of 50 over 3. And this is my answer over here. So let's try and take another example. So let's say we have integration of sine x dx from 0 to pi. Please note here that our upper and lower bounds are in terms of pi, are in radians, so make sure to change your angle degree in your calculator to radians. So again, the first step is to integrate normally. So we know that the integration of sine is negative cosine, so this is going to be negative cosine of x evaluated from 0 to pi. So this is going to equal minus cosine upper bound, okay, and then subtracting minus cosine of the lower bound. So cosine pi is minus 1, so minus times minus 1 is positive 1, and this is going to be minus minus, so it's plus cosine 0. So what is cosine 0? Cosine 0 is basically 1, and 1 plus 1 is 2, and this is my answer over here. Let's take another example. Let's say we have the integration of 2 to the power of x with respect to x from 0 to 3. So over here, this is kind of a special thing. You need to rewrite it in a way that's integrationable. So what we can do is we can rewrite this as e to the power of ln of 2 power x. Why did I do that? Because I know that e to the power of ln a is basically equal to a. So our a here is 2 power x. So I just rewrote it, okay? And why did I do that? Because I know that I can write this as e to the power, I can take this 2 to the power of x, I can take this x and multiply it to ln over here. These are the properties of natural logarithms and logarithms in general. So it's going to be x times ln of 2 dx. So over here, I can integrate. This is now similar to integration of e power 2x, let's say, because this ln 2 is just a number, just similar to this over here. So what is the integration of e to the power of x? It's basically e to the power of the same thing. Wait, this is no longer integration. We finished the integration. So e to the power of x ln of 2, and then we divide by the differentiation of this function. This is the reverse chain rule. So we divide by the differentiation of x ln 2. So what's the differentiation of x times any constant? It's basically that constant. So the differentiation is ln 2, so we divide by ln of 2, and we evaluate this from 0 to 3. So this is going to equal e to the power of 3 ln 2 over ln 2 minus e to the power of 0 times ln of 2. So basically e to the power of 0 over ln 2. So over here, what I can do is I can remember this property. I can reverse it over here to make this 3 go to the power position. So it's going to equal e to the power of ln of 2 power 3 over ln of 2. This is minus anything to the power of 0 is 1, so 1 over ln 2. Over here, I know that e to the power of ln of anything is basically that thing. So this is going to be e to the power of ln 2 power 3. So this is 2 power 3 over ln of 2 minus 1 over ln of 2. 2 power 3 is basically 8. So I can change this with 8. I have a fraction subtraction, okay, and I have a common denominator which is the same, so I can subtract the numerator. So 8 minus 1 is basically 7 over ln 2. I can leave this answer as this, because if I would do it in the calculator, it's just going to give me a decimal answer where I will need to round it. This is the exact answer, and I can leave my answer like this. So let's take a look at another example which involves, I'm not going to tell you, let's see. So 7 to 12, okay, integration of square root of x minus 3 dx. So over here, and I did a video on u substitution. Please feel free to check it out. I'm going to leave its link on the top right hand corner. This is a u substitution type of question. Why? Because I can substitute u as x minus 3, and differentiating this expression du by dx is going to equal, differentiation of minus 3 is 0, differentiation of x is 1. So that makes du equal to dx, and now I can substitute everything. So I can rewrite this as integration of u du instead of dx. Note here something very important. I cannot substitute the exact same bounds for as the previous line. Why? Because these bounds were with respect to x and dx. Whenever you change your variable, okay, for any reason, the bounds change. You have two options. Either you can change the bounds, or you can finish your integration, return it back to x, and use the same bounds. I'll show you both ways. So first, let's do the way of changing the bounds to adapt to our u now. So our u is equal to x minus 3. So when x equals 7, which is our lower bound, u is going to equal 7 minus 3, which is 4. And when x is equal to 12, u is going to equal 12 minus 3, which is 9. So my new bounds are now 4 to 9. And now I'm ready to do the integration. So I'm going to integrate this super normally. Oh, by the way, this is square root of x minus 3. So this is square root of u, okay? Or basically u power 1 over 2. So adding 1 to the power, dividing by the new power. Adding 1 to the power is u power 3 over 2. Dividing by the new power, dividing by 3 over 2 is the same as multiplying 2 over 3. And evaluated from 4 to 9. So this is going to equal 2 times 9 power 3 over 2 over 3, and then minus 2 power 4 this time, power 3 over 2 over 3. So evaluating this, putting this on the calculator is going to give me a value of 38 over 3, and this is my answer over here. Right. Let's try to solve using the other way and see if we will get the same answer. We should get the same answer. So the other way is basically not changing those two. So coming here, okay, integration of u power half du. I'm not gonna change the bounds. I'm just gonna leave it. I'm gonna do my normal integration, which is gonna be u power 3 over 2 over so times 2 over 3. Okay, and then I'm gonna say that this is equal to 2 over 3 multiply u, which is x minus 3. So I'm gonna change it back to x minus 3. So u power 3 over 2, so x minus 3 power 3 over 2. And now, since I returned it back to x, I can use the same bounds with respect to x. So this is gonna be from 7 to 12. And I can say that this is going to equal 2 over 3 times 12 minus 3 power 3 over 2. And then subtracting 2 over 3 times x, which is 7 minus 3 power 3 over 2. And if you plug that into the calculator, you will find that your answer is also 38 over 3. So both ways work. However, it's always smart to see which way is easier. In this example, I think changing the bounds is easier, but it's not always the case. So always see which is easier, and you can solve with whatever way you feel comfortable with. Okay, let's take another example. Let's say we have integration from 0 to 5 of e to the power of negative x dx. Again, first step is to integrate normally. So integrating e to the power of negative x is basically e to the power of negative x, and then dividing by the differentiation of what's inside this e function. So differentiation of negative x is basically negative 1. So dividing minus 1 is the same as just saying minus e power negative x. This is going to be evaluated from 0 to 5. So it's going to equal minus 5 minus e power minus 5, subtracting minus e power minus 0 or power 0. There's nothing called minus 0. So this is minus e power negative 5. Minus times minus is plus. E power 0 is basically 1. So over here, I can rewrite my answer as 1 minus e power negative 5, and I can leave it like that or change it into decimal, whatever I feel like I want to do. Okay, let's take another example. Let's say we have the integration of x sine 2x dx from 0 to pi over 2. Again, this is radians, so make sure to calibrate your calculator respectively. So over here, I can see that this is something multiply something else. I have two terms. This looks like an integration by parts question. So let's see. We need to choose our u as something that's easily differentiated. So x is super easy to differentiate, okay? And our dv is going to equal sine 2x dx. It's going to equal the rest, basically. Now, differentiating du respect to x is going to equal 1. So basically, I can rewrite this as du equal dx times 1 or equals dx. And then v is integration of that. So what's integration of sine? Is basically negative cosine 2x, and then I need to divide by the differentiation of what's inside. So the differentiation of 2x is basically 2. And now I can use the formula that says that my integration by parts is going to equal uv minus integration of v du. So over here, what I need to do is I will need to multiply u times v. So it's going to be, let's take the minus half outside. So minus half x cosine 2x, and this is evaluated from 0 to pi over 2, okay, and then subtracting integration from 0 to pi over 2 of v du. So what is v? Is minus cosine 2x over 2. Du is basically dx. So over here, this, I'm gonna leave it as it is right now. So it's going to be minus half x cosine 2x from 0 to pi over 2. Minus times minus is plus. Integration of cosine 2x is basically sine. And actually I can take this minus times minus is plus. I'll take this half outside. So plus half. Integration of cosine 2x is basically sine 2x. And then divide by the differentiation of 2x, which is 2. Evaluate it from 0 to pi over 2. So let's do the substitution now. So this is going to equal minus half times x, instead of x is pi over 2, cosine 2 times pi over 2, and then subtracting when I substitute with 0. However, I can see that substituting 0, I have an x over here. So when this is 0, the whole thing is 0. So I'll just say minus 0. And then plus this bit over here. So half multiply sine 2 times sine of 2 times pi over 2 minus sine of 2 times 0 is basically 0 over 2. So over here, this is going to be minus half times pi over 2 is basically minus pi over 4 times cosine pi over 2. So what's cosine? 2 times pi over 2 is basically minus 1. So multiplying minus 1. So this and this will cancel. Plus half times, okay, sine times, okay, 2 times pi over 2 is basically becomes pi. So sine pi is 0. So this whole term becomes 0. Minus, okay, sine 0 is also 0. So 0 over 2 is 0. So this whole term also becomes 0. So my answer at the end is going to be pi over 4 times 1, which is pi over 4. And this is my answer to this question. Okay, let's take another example. Let's say we have the integration of 1 over square root of 1 minus x squared dx from half up to 1. So the first glance, you can see that you have a 1 minus x squared, and you know that our trigonometric substitution, which I will leave a link to on the top right hand corner, super important video. I can, whenever I see a 1 minus x squared, I can think about this substitution. X equals sine theta. So over here, I can solve this using trigonometric substitution. So this is going to equal integration of 1 over, now x is equal to sine theta, dx by d theta is going to equal differentiation of sine, which is cosine theta. So dx is basically cosine theta multiply d theta. So now I can do my substitution to the square root of 1 minus x squared. X is sine theta, so x squared is sine theta squared, or sine squared theta. And dx is basically cosine theta d theta. Over here, this is the reason why I substituted with sine theta. And by the way, x equals a sine theta. Okay, the substitution is x equals a sine theta. Okay, whenever I have a squared, whenever I have a square root of a squared minus x squared, I will substitute x equal a sine theta. So a is basically the square root of a squared. So a squared here is basically this value. So a squared is 1. So that makes a equals square root of 1, square rooting both sides. So a equals 1. So it's basically 1 times sine theta, or just sine theta. That's why I didn't include the a over here. Okay, so now 1 minus sine squared theta from the trig identities, I know that this is equal to cosine squared theta. So I can rewrite this as integration from half to 1 of 1 over square root cosine squared theta times cosine theta d theta. Over here, the squared is going to cancel with the square root, and cosine theta will cancel with cosine theta, and I will only have an integration of 1 d theta, which is from half to 1. So doing this integration is super simple. This is going to equal, and by the way, again, I did a substitution, so I cannot use the same bounds. I have two options, okay? However, now I'm just going to complete my substitution, reverse it back, and then do the same bounds. So the integration of 1 d theta is basically equal to theta, okay? And right now, what I need to do is I will need to change this theta back. So I know that x equals sine theta. So if I take arcsine of both sides, then this becomes theta equals sine power -1 or inverse sine of x. So this is equal to inverse or arcsine of x, and now I can put my bounds, which are half and 1. So simply this is going to equal sine inverse of 1 minus sine inverse of half, and this is going to give me an answer of, okay, sine inverse of 1 is basically pi over 2, and minus sine inverse of half is basically pi over 6. So pi over 2 minus pi over 6 is equal to pi over 3, and that is my answer over here. Okay, now let's take final example. Let's take one more example. Okay, let's say we have the integration of x minus 1 over x squared plus 3x plus 2 from 0 to 1. Okay, first glance, this looks like a partial fraction decomposition, okay, type of question, which by the way, I also did a video on, and I'm gonna leave its link on the top right hand corner. Go check it out. So first of all, the first step is to make sure that the numerator and the denominator are no longer factorizable. Numerator is not factorizable, however, the denominator, I can still factorize it more. So this is going to equal integration from 0 to 1 of x minus 1. I can factorize this. This is a quadratic. I know that 2 times 1 will add up to 3. The first step is to look at this sign. This is plus, so I'll need two factors that will add up to 3, so 2 and 1. And by the way, I did a whole playlist on quadratics. I'll leave a link to it as well on the top right hand corner. Go check it out. So this is going to be x plus 2 times x plus 1 dx. This is dx. Okay, so over here, this, I have two linear factors, so I can rewrite this whole thing as integration from 0 to 1 of a over the first linear factor plus b over the second linear factor, all with respect to dx. So over here, I will need to find my a and my b values. So let's work on that. So this fraction, I need to write it like this, in this form. So what I can do is I can multiply both sides with x plus 2 times x plus 1. So over here, both of them will cancel with this. So I'll just have x minus 1 equal a over x plus 2 times this expression. I will see that the x plus 2 will cancel with the x plus 2, and I'll just be left with a times x plus 1. Plus again b, the x plus 1 will cancel with the x plus 1, and I will have a b times x plus 2. So over here, I will choose some x values, okay, to find the a and b value. I know if I chose x equals minus 1, minus 1 plus 1 is going to become 0, and this whole term will become 0, so a will be eliminated and I can find b. So let's do that. So when x is minus 1, this is minus 1 minus 1, so it's minus 2, equal, this is 0, plus b times minus 1 plus 2 is basically 1. So from here I can say that b equals minus 2. Again, if I substitute x equals minus 2, I will make this whole term goes to 0, and that will help me find a. So minus 2 minus 1, that is minus 3, equals to a times minus 2 plus 1 is minus 1, and then plus this term is 0 because minus 2 and plus 2 is 0. So this gives me an a value of 3. So now I can rewrite this expression or this integration as a equals 3 and b equals minus 2. Okay, and now I'm ready to integrate. So integration of this is going to equal 3 ln of x plus 2 minus 2 ln of x plus 1 evaluated from 0 to 1. So let's substitute our upper and lower bounds. So upper bound first is going to be 3 ln of 1 plus 2 is 3 minus 2 ln of 1 plus 1 is 2. And then this whole thing subtracting the lower bound. So it's going to be 3 ln 0 plus 2 is 2. And then minus 2 ln 0 plus 1 is basically 1. So over here, what I have is I have 3 ln 3 minus 2 ln 2, and then minus 3 ln 2, and then minus times minus is plus 2 ln of 1. So I know from logarithm or natural log properties, I know that if I have ln x minus ln y, this is equal to ln of x over y, and if I have a ln x plus ln y, this is equal to ln x times y. So over here, I know that this ln, this and this I can combine, so it's 3 ln 3 minus 3 ln 2, this is going to equal 3 ln of 3 over 2. And then this over here is going to be 2 ln 1 minus 2 ln 2, so it's going to equal plus 2 ln of 1 over 2. So I can leave it like this. I can put it on the calculator and get a decimal value. However, I can simplify more. I can use the fact that I can put this in the power position and this in the power position. This is going to be ln of 3 over 2 all to the power of 3 plus ln of half all to the power of 2. So this is ln of 3 power 3 is 27 over 2 power 3 is 8 plus ln of 1 power 2 is 1 over 2 power 2 is 4. And I know that I can say that this is equal to ln 27 over 8 times 1 over 4. So this equals to ln of 27 over 8 times 4 is basically 32. And this is my final answer to this question. I hope this video was helpful. Please don't forget to like, subscribe, and give me a comment and suggestions down below. If you have any questions, feel free to leave them. Thank you for watching and have a nice day.